Hello and welcome back everyone. How are you all doing? This will be the third part of enemies. And as promised, we will add some behavior today. They will be able to spot the player, chase the player, and finally attack the player. So don't forget to subscribe and like the video. There's more to come and you do not want to miss that. And as a reminder, all of the code and assets can be found on my website or on GitHub. If you have questions about this tutorial, or maybe you get stuck somewhere, check out the Discord link. And if you want to go the extra mile to show your support, there's a link below where you can buy me a coffee. Even though I don't drink coffee, I'm a tea guy. A few days ago, I put up a poll about the recap section in my videos. It's just something I added a long time ago, but I was not sure if people liked it or not. So I had a poll, and the result was quite clear. The recap stays. So, without any further ado, here's a recap from the last episode. We started off the episode with some quick fixes that were pointed out by the community. Then, we gave our enemy a hitbox to be able to navigate and detect the level around itself. We also gave it some draw offset values to make sure that the image of the enemy stays in the center of the hitbox. We spent most of our time in the update move method. We began by having a function where the enemy falls to the floor at the start, and once on the floor, he can then start to patrol. With some simple commands and checks for the level, our enemy can now patrol without getting stuck. Before we really get into coding new stuff, we need to move around some code actually. And the code we're gonna move is from the enemy to the Krabby class. So let's just grab enemy here and put it on the side, and then we have Krabby on the left and enemy on the right. Alright. So we're gonna move most of this update move, the switch, etc. over to our Krabby, because the crab is gonna have different behavior compared to any other type of enemy. So we need a switch in the crab, and then we just call functions in our enemy class that both enemies or all the enemies can use. So let's just grab update move method, all of it, and place it here in Krabby. And then we will need to go to the top of our enemy class and change all of these variables to protected. The private variable is only accessible to methods and variables inside the class, but protected allows us to use it in other classes that extend the enemy class. So we're just gonna change these to protected, all of them, and then save it. We should get far less errors. All right. And then after update move, we're also gonna take the update method actually. The big update that we calls every method in the classes. Update AnimationTick is red, and that's because it is a private in our enemy class where it needs to be a protected variable, or rather method. And we might as well change walk there as well to protected. Anything else? Nope, it all looks good. Perfect. So we should get rid of all the errors, and if you try it, it still works. Beautiful. Then we're gonna simplify this update move method because it's a lot of clutter here. We don't really know right away what it's doing. So for our first update, we are gonna make a method in our enemy class because we might need to do the same first update check in crab as well as other enemies. So we're gonna make a method here, and of course we need to keep it protected. Void first update check. So it's going to do the same as what's going on here, but we simply keep it in a method, and then when we need to do it for another enemy, we can just call this method. But this method needs to take in the level data, so let's just copy that. Then we simply take this part right here and place it in here. And we can remove the brackets, and then we take and just call first update check in the update move. And it's looking for that level data, my bad. We need to pass that along. So now it's updating and we have it in here. Perfect. And we're gonna do this for our in-air check as well as our update move, or rather our moving here. So 2 more things before we actually start adding new code. We need to move it and simplify it before we actually add any new code. So the second method we're going to create here is for our in-air check, or rather our update in air, so to speak. So in our enemy class, we add a protected again, void update in air. Just like our first update, we need to keep the level data as an input because we need to know whenever we are hitting the floor. So let's just see here. In air, we grab all of that, right? Yeah, and then just place it in here. Perfect. And then of course we need to call it update in air level data. And we can remove those brackets. All right. And the last method we're going to create in the enemy class is for our, well, move part, where we are moving the player. So public void, not public, protected void. Let's just call it move. I think that's a pretty good name. And you guessed it, we still need the level data. So we're going to take that and add it as an input. And then we simply grab all of this and place it in here for our move. And then in our running section here for our update move, we say move level data, like so. And that looks much cleaner. Now we can actually call this method move, not just from our crab, but from another enemy as well, without having to actually code it all out again. And just to check whether or not everything is working, so we didn't break anything. All right, it looks all right. It looks like it's working. Perfect. I actually want to add another method here, protected void, and it has to do with our enemy state whenever we are changing the state from one state to another. And it's just going to be called NewStance, and it's going to ask for an integer enemy state. And it's going to change the current enemy state we have to the enemy state we're giving it. And then we're also going to say AnimationTick equals 0, as well as AnimationIndex equals 0. And that's just something I like to have. Whenever we change the state, we want to have a new fresh animation tick as well as index. So we don't start in the middle of the animation. So that's why, and whenever we change the state, we simply call new state running, or running, like so. So whenever we change the state now, we also call AnimationTick to 0 and AnimationIndex to 0, which is also needed. All right, then we can start getting into how the enemy will behave in our game. Some of this we already have, but some of this is also new. So let's take it from the top. The game starts, we start checking if we are in the air or, keep falling. Are we on the floor yet? No, then we keep falling. But at some point we're going to say, are we on the floor? Yes. Then we go to the enemy state idle, and right away from idle to the running. And this is where we are right now. We can call running, patrolling, whatever you want. We are in here. And then this is what we're going to start with, is to check if the player is in sight. First, what we're going to check is if the player is within the range that the enemy can see. If he's outside that range, then we don't have to check for any line of sight or anything like that. First, we're going to check if the player is in that range. If it's true, then we're going to check whether or not there is any solid tiles between the player and the enemy. Meaning if it's just a flat surface, there is no obstacles in the way. And we're also checking to make sure that there is no open spaces like a pit that the enemy can fall into. If there is a pit, then the player is not in sight. Or is there a solid tile between the player and the enemy, then the player is not in sight. If the player is not in sight, then we go back to running and keep doing this until it turns true. Now it says, yes, we can see the player. It's in sight and there's no obstacles or edges between us. And whatever this means is that we're gonna target the player. We're gonna keep doing moving like normal, but we're gonna set the direction of the enemy towards the player. So if the player is on the right, then we're gonna set the walking direction to right. And then we're gonna keep updating the move until this one, is the player in range, is true. And at some point we're gonna check, is the player in range? Meaning that the player is gonna be close enough to the enemy, so whenever the enemy is attacking, the player will take damage. And if it's a no, then we just go back to, is the player in sight, move towards the player, etc, etc. Keep looping here. But at some point we're gonna say, yes, the player is close enough. All right. Then we go to our attacking state, meaning we're just switching to an attack. And it's gonna be one animation loop per attack, meaning that the attack is gonna consist of one attack or one animation. So when we are attacking, it's gonna be a few sprites in this entire animation. I think it's 7 sprites in total. So when we are at the last sprite, all the animation tick is over, etc. The attack is over. So if it's over, then we go back to idle and we repeat this entire loop. So if the player is still very close for attack, so we're gonna go right from, is the attack over, idle, running, players in sight, move towards the player, and is the player in range, and then we attack again. So it's gonna go very fast, but we go back to our idle state right after an attack. So this is how we are going to code our enemy. Some of this code is already in the game as of now. Other parts like the attack and insight, etc. we're going to add in a second. So without further ado, let's continue the episode. And most of the methods we're going to add today is actually going to be inside our enemy class. And that is because so that we can use the same methods for other types of enemies. So let's begin by adding the first new one, which will be the one where we check if we can see the player. So protected void CanSeePlayer. And we're gonna do a few different checks in here. First we're gonna see if we are on the same tile in the Y axis, meaning if the player is on tile 8 in height and the enemy is in tile 9, then they're not on the same tile, so we're not gonna check any more than that. So that's the first check we're gonna do. But before we start coding in the method, we are going to need 2 things. We're going to need the level data, and we're going to need the player. And the player we're gonna get from our update move, which is gonna get it from our update, and we're just gonna pass the player in alongside the level data as we've done here. But let's focus on the method for now, and then we're gonna go and get the actual player variable. So first we're gonna check int player tile y is equal to player.get hitbox.y divided by game.tile size. So this will take the current y position of the player and turn it into the current tile y, because we're dividing it by the size of the tile. And we need to recast this into an integer so we don't get any float values to that variable. So now we have the player tile, and now when we have the player y, we can also do exactly the same calculation for hitbox.getY divided, etc. But we don't need to do that calculation every update, because the tile y for the enemy will never change. It will always be the same tile. It will always have the same y value. So we're gonna actually put this tile, first of all, we're going to need a variable. So we're gonna protected int tile y, and this tile y we're gonna put inside our update in air when we are actually hitting the floor. So right underneath our hitbox.y, when we get the entity, get the position, when we're hitting the floor, we say tile y is equal to, recast it to int, just like the player, and then we say hitbox.y divided by the game.tile size. Like so. And now we have the tile y for the enemy, which will never change. So here we can then check if player tile y is equal to tile Y, meaning they are on the same or they are not on the same. Then we can check isPlayerInRange, and this range is the maximum range that the enemy can see regardless if there is a obstacle or not in the way. We're just gonna get, is it inside the maximum range that the enemy can see. So we're gonna have to place a player variable in here, and we're gonna get to this method in a second. If that's the case, then we wanna check if IsSightClear, meaning can I see the player and is there also no obstacles in the way? If that's the case, then we know that they can see the player, and we will return this, not void, but boolean true. Otherwise, if any of these fails, then we return false. So we can put return false down here. But if the site is clear, and here we need to pass along a few things. We need to pass along the level data, because we need to know for obstacles. We need to pass along the hitbox, the enemy hitbox. We need to pass along the player.hitbox. And then, of course, the current tile Y. So we need to know what tile Y we are actually checking any obstacles for. And if this method says that the site is clear, then we're returning true, and we can now move on to the next stage. But let's begin with this method first, is the player in range. Before we can actually code this method out, it's going to be like 2 lines or something. We need to determine what is the range. How big should this range be? We are going to have 2 different ranges. We're going to have one for visual and one for attacking. So that the attack range is most likely going to be much shorter than the visual range. So if you go to the top and declare the attack range, so protected, float, attack distance, and we're gonna set that to, let's set it to 1 tile, so game.tile size. So the attack distance is going to be the size of a tile. Very simple. We can change it later, of course, if we want to. So to keep it simple, let's set the actual visual range to a multiple of that variable. So let's say 5 times the attack range is the visual range. And then we also need to know the range between the player and also the enemy. And we can get that by using something called absolute, or rather a absolute value. So ABS value is equal to math.abs, and absolute in math means simply the distance between 2 points. So to make it simple, let's say 10 or 100 minus 50, we know the range is 50. But if we had 50 minus 100, meaning one was on the 50 and one was on the 100, we don't know which one will be higher or lower. This would result in negative 50. What absolute is doing is just returning the actual distance, so it will not be a negative ever. So that saves us a lot of debugging. So we're going to say player.hitbox.x minus hitbox.x. And this is going to return the absolute value for those 2 points. And then we simply return ABS value is less or equal to attack distance times 5. We could keep the visual longer or shorter, but let's say 5. So the attack distance times 5. If the absolute value now is lesser than that, it's going to return true. If it's larger, it's going to return false. So if it's true here, then we go down to is the site clear? And this method is actually not going to be inside our enemy class, it's going to be inside our helper or help method class. And because it's going to be a public static, it should be isSightClear with a capital S. So into our helper method class. And the reason why we place this method in our helper methods class, it is because it's one of those methods that you can use everywhere else. because we're checking if there is a line of sight between 2 points. And it might not just be the player and enemy, it could be projectiles and what have you. So that's why we're going to place it in the helper method class, so other classes and objects may use this method. And it's going to be a public static boolean IsSightClear. And if we look what type of values, we need the level data first, and I'm lazy, so I'm just going to copy from somewhere else. And then we need hitbox, and hitbox, we're going to need 2 hitboxes. We're going to need a hitbox, let's call it first hitbox. And then we're going to need second hitbox. And then it was the actual Y tile that we are working on. Let's see if that is correct. Level data, hitbox, hitbox, tile Y. Yeah. So it's a long method, that's okay. And we can call return false at the bottom just to get away the error message. And the first thing we're going to do in here is to figure out what X tile the first hitbox is on, as well as what X tile the second hitbox is on. So just like we did with our Y tile, we're going to do the same, but for X here. So first X tile equals first hitbox.x divided by game.tile size. And we of course need to recast that over to an int so we don't get any floats. And we are actually going to copy it because it's going to be very similar. Then we call second X tile, and it's not going to be the first hitbox, it's going to be the second hitbox, like so. And what we need to do now is to check if there is any type of obstacle from the first hitbox to the second hitbox. And our platformer, we don't need to check every 5 pixels or 10 pixels or anything like that. All we need to do is check each X tile between the first hitbox and the second hitbox. That will make our loop much quicker. And we're going to do that with a for loop. And before we use the loop, we are actually going to check if first X tile is larger than the second X tile. We need to do this check because if we are looping and one of the tiles is bigger than the other one, we might get some weird errors in our loop because we're not actually increasing. We should actually decrease to get to the other tile. So this is just to make sure that our loop works correctly. So in this bracket, we add a for loop. Int y equals 0. I is less than first X tile minus the second X tile. So now we get the difference between those two. And then I++. So now when we get the actual tile, we need to check whether or not that tile is solid. But we could of course use isSolid, the one we have already up here. But we don't need to do anything of this. We just need this, because we know that we already are within the max width and max height. We're not gonna get any errors or leave this method from that section. So let's actually change this one up a little bit. Yeah, let's do that. So public static boolean is tile solid, and it's going to take in int x tile, int y tile, and of course the level data. And then we're gonna take this section, place it in here, and instead of casting it over to integers, we're gonna say x tile in there and y tile in there. And in here we say return is tile solid. And we're gonna pass in the x, but it needs to be recast over to an integer. And we're gonna recast this one also into an integer, and it's gonna be the y index. It's doing exactly the same, but now we can call this method right here without having to do all of that whenever we're checking if the tile is solid. So it's asking for the X tile, which will be starting from our second tile because it's smaller than the first tile. So second X tile plus I. We're still on the Y tile, that will never change, and then we pass in level data. If that one is solid, meaning we find something that's solid, then we return true. That's pretty much it for our loop here. Well, what if our second tile is bigger than our first tile? Well, then we just add a else here. And we might as well copy all of this. We don't have to rewrite it all over again. And we're gonna switch from the first X tile, and we're gonna say second X tile minus the first one. And we're not gonna start from the second tile, we're gonna start from the first tile, and we're gonna return true. And you could clean this up because we have two loops that are identical almost, and if you have code that's very, very similar, usually there is a way to simplify it and have less code with just calling a method that have that type of code. So a public static boolean is all tiles walkable, and it's gonna take in an int x start, a int end x or x end, and then it's gonna take in int y and also the level data. So I'm gonna copy that because I'm lazy, and then some brackets like so, and then we just copy this and then we paste it in here, but we're gonna return true if it's never returning false, or rather we never find any type of tile that is solid. So we're gonna need to change a few names here. So first tile, rather x end, and then start x, like so. The bigger and the smaller. Then we have a range, and then from the start, then for y, like so. And now we can just return is all tiles walkable, first tile, second tile, y tile level data. And make sure that the first tile is bigger, so it needs to be other way around. Second hitbox, second X tile, like so. Copy this, replace this, switcheroo, like so. And then we can remove that section, remove the brackets. And I must say it so myself, it looks much cleaner. Just to make sure that it works. So if this one is bigger, then we need to start from the second, and the second is placed in the first here. And it starts from X start to the end X. Yeah, that looks all right. And Y will never change. Y is there, tile solid. Yeah, it's a lot of code, but it's looking quite neat now. And I think we have done all the code that we can do for our CanSeePlayer. So first we get the player Y, then we're checking the player Y with the enemy Y if it's the same. Then we're checking is it in range, and we're doing that down here. And in this case, attack distance times 5. Then we're calling IsSightClear, and we go over to our helper method, and we get the tile for the first hitbox and the second hitbox, and in this case it's the enemy and the player. We are doing a loop depending on which one is bigger than the other, and then we're checking if any tiles in that in between them are solid. If they are solid, or we find a single solid tile, then we return false, and that means that all tiles are not walkable. So this one returns false, or this one returns false, and we leave that. Otherwise, if there is no solid tiles found, then we return true. And if this one returns true, we can see the player, then of course we should go to move towards the player and then isPlayerInRange. So now let's just do the move towards player. And this is going to be a piece of cake compared to the code we just added. So protected void turn towards player. And we need, of course, the player object, player, and we need some brackets, like so. And all what we're going to do in here is simply if player.hitbox.x is larger than hitbox.x, meaning our enemy hitbox, then we say walk there is equal to right, else walk there equals left. And it's not more complicated than that. We're simply checking whether or not the player is on the left side of the enemy or on the right side of the enemy. And we know that whenever we update our move, we're gonna go in the direction of our walk direction variable. So this is all we need to do, and that's it. So now we need to check if the player is in range for an attack. And that too is going to be very simple. Let's place it next to our isPlayerInRange. So right underneath here, I see it's a private. It should be a protected, of course. So this one should also be a protected. Boolean isPlayerCloseForAttack. And we're only going to need this one, player object. We can actually copy all of this and place the same here. But instead of attack distance times 5, it's just attack distance. They're very similar, but the difference is the size of the range. And that's it. Before we can truly test this and see if everything is working, hopefully it will, we need to do 2 more lines. And that is inside our update animation tick inside enemy class. And remember when I said that we will only do 1 attack at a time and then we will go to our idle stage. And that is going to be inside our update animation tick. So right here we completed our current animation, could be whichever, doesn't matter. But if animation or enemy state is equal to attack, if that's the case, then we simply say enemy state is equal to idle. So we're changing the state to idle as soon as we are done with our attack. And that is how we go from attack to idle, and then we restart the entire loop again. So this is very crucial, otherwise we will never leave the attack animation. Now comes the fun part. And that is to take everything we just coded and place it inside our update move method here. And more specifically inside our running section. So first we're gonna say if can see the player, and in this can we see the player we have a check if we are on the same tile Y, is the player in range, and is the site clear. And right off the bat it's asking for a player variable. And we don't have it, so we need to ask for it. So we say player, and we can copy this because we're gonna need to type it out a few times. And we're gonna need it inside our update method here. Gonna pass it to our update move. Gonna copy that once again. Error in our enemy manager. So we're gonna need a player variable here as well. Pass it along. Save it. Error in our playing, and in our playing we say just player to our update method because we have the player already. We are creating it in our playing. So player in there, can close that one down, pass to enemy manager, close that one down, into our Krabby class. So if we can see the player, then we want to say turn towards the player. And once we've done that, we want to see if is player close for an attack. If that's the case, then we say new state attack. Simple as that. And that should work. It shouldn't be more difficult than that. We might have an issue when it comes to edges or other pits. So let's give it a try and see how it looks. It started up. He's patrolling like he did before. Let's see. I run towards him. He changes direction. He comes close and he attacks me. Ouch! Ouch! I run away. He stops attacking. He comes towards me again. I jump over here, up here. Let's see what happens here. He changed direction. He's now just patrolling. But what happens if I aggro him? I'm over here. He wanna get to me, but he can't. So let's fix that and let's see how to fix that. And to solve that, we don't have to do much. We only have to go to our CanSeePlayer method and the one that's called IsSightClear. We have yet another jump to one called IsAllTilesWalkable. I actually renamed it to AllTilesWalkable, not AllTileWalkable, without recording. So it might have an extra S here if you didn't recognize it. So in this method, we're checking each tile between the player and the enemy. If there's any tile there that's solid, we return false. But we could add brackets to this loop. And after we check the tile between the enemy and the player, we can actually check the tile underneath that tile. So if not is tile solid, because if the tile is not solid, then we're trying to walk in air and we can't walk on air. So if not tile solid, you know what? Let's just actually copy this entire one, paste it, and let's add a not is tile solid, but we go +1 for Y, meaning we're checking the one underneath. And if it finds a solid, then it goes to the next. But if this one returns true, meaning that there is no tile that is solid underneath this one, then all tiles are not walkable. So let's give this another try and see if the enemy just stands in the same place and runs. So let's go get him. Come here, boy. There we go. Let's see. And he turned around. Perfect. Alright, I think this is a good time to stop. I remember at the start of this episode, part 1, I said that there would probably be 3 parts. But I think there will be another one, so 4 in total. I don't want to make this part so much longer than the rest of the other ones, so there will be 4 parts in total. And in the next update, we will focus on combat. Player killing the enemy, and also enemy hurting or killing the player. So don't forget to subscribe. The next part will be what puts the entire episode to an end. Until then, take care now and have a wonderful day. Bye.